Hello, welcome to this video. Today we want to look at the perpendicular lines. So just before you understand what perpendicular is, this is what happens. So when you draw a graph and you have two lines, so like you can see here in question A, you have two equations of different lines, and you want to just prove, for example, without drawing, this is just when you do calculation, you want to prove whether these lines are perpendicular without drawing those lines on the graph. So perpendicular means basically if you have a line like, let's say, A and B, like this line A, then B should be cutting it, crossing line A at 90 degrees. So if B is then we say now B and A are perpendicular. So now in this case now, if we want to focus on the idea of perpendicular lines, whether these lines are perpendicular, whether we want to determine, yes, whether these two lines that we have, the equations are perpendicular without drawing, then we have to ensure, we have to find a way, we have to find the product of the gradients of those two lines. And if we find the product of the gradient of two lines, and the product, the final answer we get is -1, then we know that these lines perpendicular, crossing each other at perpendicular point. Okay. So the lines are perpendicular to each other. So that's the most important thing. Now, if we have this equation, we have three examples here. We have A, B, C. Now, we want to check by calculating and finding then the product, or multiplying the products of, yes, of the gradients, and see whether they are whether it's -1. If the result is -1, then they are perpendicular. You just want to know among the, like, we have three examples here, whether the three examples that we have here are all lines that are perpendicular to each other or not. So now let's go to the first question. We did, in the previous video, we worked with gradients. And if you want to see, that we also emphasize on leaving your equation of the line as y equals to mx plus c, which is the constant. So if you have an equation like this, normally this m is the gradient. So that's going to give us an easy time to find what actually is the gradient here. So the connotation of the variable that we have here with x, or the value that we have here, the value of x, that's always there from the equation. So that's always the gradient. So now when we look at y minus 2x, we can easily make that value in the format of y is equal to mx plus c, and then we'll find out what is the gradient. So we're going to take the first line to put it in this format. So we're going to say there y. So this is the -2 minus 2x. If it crosses this other side, it should give us +2. So equals to, so this one is going to be, and 7 here is also positive. So we're going to have here 2x plus 7. That's equation 1. Equation 2, we also want to make that one clear, because to make it in this format, so here we have 0. So we're going to have here, we're just going to remain with y equals to, we have 3, it's -3 this side, so it should be +3 the other side. A half, 1/2x is positive, here should be negative. So we're going to have here minus 1/2x plus 3. So we have 3 here, which is minus, so it comes this direction, it becomes 3. So that is equation 2. Now, when dealing with this now, we want to check whether these two lines are perpendicular to each other. So it's easy. We're only going to take the gradients and multiply. And if we get an answer as -1, then they're perpendicular. So the gradients, like I said, is now the m here, this one. So we're going to say 2 multiplied by 1, -1 over 2. Of course, that's going to give us -1. So our note is we're going to say here, that line A, so they're perpendicular to each other. So A is perpendicular. Now let's look at B. So B is also going to be the same method. So we would just want to make sure that all our figures are made in the format of y equals to mx plus c. So in this case now, we're going to take the equation 1. We're going to say here we have 3y, so we have to divide everything by 3. Okay, so that we have y here equals to x over 3 plus 3 over 3 there, which is 1. So that's going to be our equation 1, because from there we're going to look at the gradient and then multiply them, and then we find out whether we have a -2, -1, and that's going to justify whether this is perpendicular or not. So now let's look at the second equation. So we still have y. We see here plus 3x. This is plus 3x is plus, so if it goes the other side, should be negative, and plus -2 should be positive the other side. So the next question will be y equals to -3x plus 2. So that's the second equation. So from here, so easy. So from here, we just go to the gradient. Like I told you, it's always this one. So this is a third. So if we look at to prove now perpendicular, we're going to say here a third multiplied by -3. So assume now over 1, so that we know that 1s will cancel and 3 will cancel. Here we're going to have -1. So being that the product of these two lines give us -1, shows that these numbers are perpendicular. So these lines here are perpendicular. So we say these are perpendicular, two lines to each other. Yeah, let's try the last one. It's always nice to work with this kind of calculation. It's just amazing experience to see the numbers. And yeah, just to prove whether the lines are perpendicular to each other. So now let's do C, the last one. So C, we can immediately even find out the first line, so we don't have to work on the first equation. So first equation, we have the gradient, which is 5. Second equation, we want to make in the form of y equals to mx plus c, so that, I mean, if you want to show, it's so easy to know what's the value of x here. But since we just want to, follow procedure step by step to make it easier for you to understand, we're going to say here, we're going to divide everything by 5, everything by 5, everything by 5. So here we're going to say now y equals to 10 divided by 5 equals 2 minus x over 5. So this can also be written otherwise, like y equals to minus x over 5 plus 2. So in this case now, the first one, we've already found the value, the gradient, the value of the gradient. Now we want looking for the value of the gradient here, which is 1 over minus 1 over 5. So now to prove whether the perpendicular, whether the two lines are perpendicular, we are now required to say, okay, we have here 5 multiply by minus 1 over 5, 5 over 1. So 1 cancels, so then we have 1. So 1 times negative 5 will give a negative 1 will give us negative 1. So as the rule goes also, we say now C is also perpendicular. The two lines for exercise C or the equation C are also perpendicular. Those two lines are perpendicular to each other. So that is all that I want to just talk about today. Just looking at the values and looking at computing the perpendicular line, and also like just looking at equations, two equations line without drawing, finding whether the two lines are perpendicular to each other. Of course, if you draw them on a graph, you're going to, of course, just observe and say they are perpendicular. But in this case, now you are given just equations and you ask, can you prove whether they're perpendicular to each other or not? So easy peasy. That's what we did now. Thank you so much for listening. Have a nice time and bye-bye.